All right, if you're doing these notes on Monday, it is November 30th, and these are types of chemical reactions. I do not like to write out the word reactions every time, so I will abbreviate it with RXN for reaction. We need to look at the basic parts of reaction before we go through the types. So we're going to have, I'm going to write out a simple reaction. We have sodium plus chlorine yields sodium chloride. We just got done with the ionic compounds unit, so that should be familiar to you. As I write it like this, over here to the left, those are reactants. And whatever is created is our product. We read the arrow as yields. Well, there's a spelling error. All right, so we have sodium plus chlorine yields sodium chloride. So for our 5 types of reactions, the first is called a synthesis reaction. And this is where multiple things come together to make one thing. So this would be element plus element yields compound. We could also have a synthesis reaction, though, where you have compound plus element yields bigger compound. So to synthesize means to come together to create or make, and these are coming together to make one thing. Some examples of this would be if we had magnesium and fluorine coming together to make the ionic compound magnesium fluoride. Now when we write this with the symbols, we would put magnesium, fluorine is diatomic, and I'll talk about that probably in our next video. Magnesium has a charge of +2, fluorine -1, so for every magnesium, you need 2 fluorides. Our next type of reaction is the opposite of this, and the opposite of making something is breaking it apart, and that is decomposition. So for this one, I have that bonded to this, and a reaction occurs. We have that. Now I will say, typically requires heat. To make something break apart. An example of this is if we had potassium iodide, we heat it up, we're going to get potassium and iodine by itself. I'm going to balance this equation. I know we haven't done balancing equations yet, but I can't stand that it is unbalanced. I have 2 iodine over here. I need 2 over here. And I have 2 potassium, 2 potassium. It's balanced. If you didn't understand what I just did, that's okay. The key here is seeing that you have a compound and then it broke apart into smaller pieces. Another example of this is hydrogen peroxide. Over time, it will break apart into water and oxygen gas. So one thing broke apart into smaller things, it is decomposing. Our third type of reaction is single displacement. And you will also hear it called replacement, single replacement. So here we have a compound mixing with an element, and it really does matter if these are positive or negative. So we'll say in an ionic compound, this is the positive, that's the negative, this is positive. And if this square finds the triangle more attractive, it will bond to the triangle and get rid of the circle. Remember, when you write an ionic compound, the positive always comes first. So you can see that these traded places, and that's the single displacement. An example of this is fluorine will break up with lithium and bond to sodium because sodium is more attractive to it. It's higher on something we call the activity series. You will not have to predict if this will occur. You will just look at something that's written out for you and say, is that synthesis, decomp, single displacement? And based on the patterns you see, you will determine what type of reaction it is. So you would see that these trade places. So we had a compound and an element, and it trades places. So now we have compound and element. Our fourth type of reaction is double displacement. Also called double replacement. And I think you can guess what's going to happen. All right, it does matter which is the positive ion and which is the negative. And in a double displacement, this is where you have two compounds. That goes there, this goes there. Again, that was positive, negative, positive, negative. An example of this, let's take iron nitride and mix it with sodium chloride, and we're going to end up with again, don't worry about these formulas and the balancing. The key here is looking at the pattern. And if you can identify that these traded places, that is a double displacement reaction. All right, the fifth type is a little different. We don't have these shapes and patterns. We have some telltale signs when you have combustion. So you need to think fire or an explosion. What you're going to have is a hydrocarbon. You're going to have some oxygen. We know we need oxygen gas to have fire. And it's always going to make water and carbon dioxide. So let's say I have CH4, oxygen gas is just O2, water is H2O, carbon dioxide CO2. The key things here that tell us we're going to have this are, did you start with some oxygen? Did you end up with water and CO2? And if you think fire doesn't make water, it really does. It produces some water vapor. All right, that's it for these notes.